Alright, so today's lesson involves slope review, which is our first chapter review. Um, One thing that I'm going to do is I'm going to focus more on formulas perspective. So instead of me going through chapter 1.1 was this, 1.2 was this, 1.3 was this, it's rather going to be a whole chapter, holistic review. First of all, the slope formula that you guys know is basically what you learned in junior high. Slope is equal to rise over run. But I'm not a big fan of this way of approach because of several reasons. And most of the time it's linguistic reason. The word rise in English and run in English may give you, how can I say, very carbon stone idea that rise has to go all the way from lower ground to higher ground and run as whatever the left point to right point. So let me point some of the thing out. Like for example, I have any type of line going from lower coordinate to higher coordinate. Slope talk about how much it is elevated. This is one of the reasons why slope doesn't have any type of unit too. Whatever the run is a meter, then rise should be in meter so that those units can be disappear. An example that I put, for example, in here is height and x, height as y and x as x run. If you think about the slope, it is basically mathematical way of showing how much it is stiff. Its stiffness. I don't know whether this is an actual term or not. So rise over run can be expressed as delta y and delta x, and that is what I prefer more because delta means change of. So if it's rise in English, that's down to up, and it's always have a concept of negative to positive, which is unfortunately not true all the time. In fact, it is one of the case when elevation go down to up. But we need to think about any type of angle of depression situation, up to down. Although rise in terms of language art perspective doesn't include that, but this up to down situation is also another valid situation. It is high to low. And because of this limitation, I like to use delta y instead of the term rise. Because delta y is basically the height gap. How much is going low to high or how high to higher up to down, which is like a drop situation. Run. When it comes to English perspective and any type of your elementary to junior high, run is like left to right. And that is very common. Think about your number line. Your number line start with the 0 all the way to 1, 2, 3, 4, 5, something like that. It progress left to right. So that means there's a carbon stone type of thinking that everything proceeds from left to right and it has to be that way. But that is again one of the perspective, left to right. In the world of math, it does include other way around too. You're starting from right and go towards left. Although this part doesn't play a huge role when it comes to math 20-3. Because of this language art or English definition limitation, I prefer using variable. Like slope, we used to use m, and instead of rise, we use delta y. Instead of run, we use delta x. So now from now on, this is actual formula way of approach, and this is very important. Like I mentioned, delta, that triangle structure, is basically Greek way of saying change of. So that means numerator is change of y, denominator is my change of x. So numerator and denominator doesn't talk about direction, it's rather talk about a gap. So numerator is vertical gap, denominator you can think it as a horizontal gap. And that is equivalent of m, which is your slope value. Again, know the fact that slope generally go with decimal value. So if it's low to high situation, we call it positive gap, because whatever upper value minus smaller value, so that gap is always positive. On the other hand, if you go up to down situation, the difference between them will be always negative. It's like 3 minus negative 2. 3 minus 2. 2 minus negative 3, something like that. And in any case, it gives you a negative gap for y value. So you can apply that positive and negative value for numerator, denominator. If you think about x situation, if it's go left and right, you can consider that as positive. Right to left, always negative, because I'm starting with the higher value going to lower value. Similar as up to drop situation, like the one that you see. This is another approach. So how can this be applied for your situation, like a roof situation? As you may know, the top of the roof, bottom of the roof, you need to find out the slope of that section. First thing that I identify is direction of the slope is going like up to down. I call it water slide situation. You're dropping, gravity pulls you. So the vertical gap is negative because you go high to low, but you're going left to right, so it is positive for the run. So slope, delta y over delta x, top numerator should have negative value and bottom value should have positive. So long story short, it will be negative decimal. And that's one of the type of the slope that you will see. Another type of the slope is basically completely opposite as number one situation. As you may notice, the run is going left to right, so it is positive, and down to up, which means positive for y value. So if I use the same formula, delta y over delta x, the only difference is sign. The top numerator is positive and denominator is positive, so all of them are positive. We call it positive slope. And you will have some kind of decimal value. And in chapter 1.2, we learn about the grade, which is percentage representation of the slope. So what you need to do is, for example, I'm going to use number 2. If you have positive some percentage, let's say positive 0.42, something like that, you need to multiply that decimal by 100%. It always works like that. Whenever you convert something into percentage, you need to make fraction into decimal, then decimal multiply by 100, or moving 2 decimal place to the right, then you will get 42%. If the value is somehow repeating decimal, you need to round it up. Generally 2 decimal place, nearest to 100. Now, another thing that you need to understand is, some question asks you about the angle. Then, there is only one trigonometry function that you need to use, tangent. Don't forget that it's second function tangent because we are trying to find an angle. And you can put the vertical gap, delta y, and horizontal gap, delta x, and that will give you the angle of any type of slope, and it'll be always positive actually. Now let's talk about our second half, which was involving Cartesian plane or any type of graph, x-axis and y-axis. That is another slope application of slope that we learned. Draw x-axis, y-axis, and you see some kind of coordinates. Sometime it is 2, or it can be more than 2. Like I'm drawing 4 coordinates in this system. And how can we find the slope based on this graph? Well, always remember it is delta y over delta x, but I'm using some advanced one, y2 minus y1 over x2 minus x1. You need to understand that the subscript 1 and 2 have different meaning. So what does that mean? 1 represent any type of coordinate that is located on the left side. Located on the left. 2 is located on the right. It is relative position. There is no absolute position except some extreme. So I can choose 1 as left and 2, 1, 2, 1, 2. Or I can decide 1 as a second, 1, 2, and 1, 2. Or third one is 1, then last one is 2. Know the fact that the last point cannot become 1 at all because I don't have anything on the left. Anything on the right. That should be the last one. So for example, I'm going to choose a second coordinate and third coordinate to give you a little quick example. And I'm putting my coordinate 2 and 5 for the first one, 4 and 3 for the second one. So I start copying the formula first. Know the fact that y coordinate is on the top. So I have to put 3 minus 5, but some people make a mistake in putting 4. Always separate that. The second number that you see on each coordinate is my y value. So 3 minus y, then 4 minus 2. Then calculate negative 2 over 2, and that is equivalent of negative 1. And that is my slope of this graph. And double check the negative. Negative is like water slide going down through the slope, so it is on the right track. That is my review.